The question says that a long straight wire in the horizontal plane carries a current of 50 ampere in north to south direction. Give the magnitude and direction of B, that is the magnetic field, at a point 2.5 meter east of the wire. So here is a physical demonstration of this question. Now we have assumed the horizontal plane as this table. Now M to N, that is M is in the north as directed in the image, M is in the north side and N is in the south side of this table. So there is a current flowing from M to N, or from north to south, and its magnitude is 50 ampere, and a point P is there away from this line Mn, which is at 2.5 meter east, that is on the right hand side of this wire, and we have to find out magnetic field at this point, and we also need to give the direction of magnetic field at this point P. So from Biot-Savart law, we know that the magnetic field due to long straight current carrying wire at a distance r is given by mu naught I by 2 pi r, where mu naught is the permeability of the free space and I is the current and r is the distance between the point P and this wire. So after substituting these values, we will get a value of 4 microtesla, that is there is a 4 microtesla magnitude of magnetic field at this point P. Now if we want to know the direction of this magnetic field, then we can use right hand thumb rule, where the thumb is in the direction of the current. So the palm will face the direction of this magnetic field, and we will see that it is upward. So the direction of this magnetic field is going to be upward. Thank you.